Welcome back to 6-Minute Statistics. In this video, I'm going to show you how to solve the final type of normal probability problem, the one where we locate the top 10% or the bottom 5% or any other percentile or probability that we're interested in. So if you're looking to figure out how to find a point in the distribution once you've been given a probability, you're in the right place. Give me 6 minutes and I'll get you there. You ready? Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics, and I want to thank you for checking out my videos and giving me the opportunity to teach you something new about the normal distribution. At this point, you should consider yourself a master in normal probability problems. You know the ones where I give you a normal distribution and ask you to find the probability above a certain point, or maybe below another point, or maybe between 2 points. Those are probability problems. The other type of problem is the one I'm going to cover here. It's called the point in the distribution problem. I give you a percentage or a probability and ask you to tell me the value in the distribution where it occurs. Let me give you an explanation in the context of an example. In an earlier video, I suggested to you that when the green mandarin fish spawn, they release an average of 400 eggs into the water. Let's say I also know that the standard deviation for the number of eggs spawned is 100 and that the distribution is normally distributed. In an earlier video, I could have asked you, what's the probability that more than 300 eggs will be released? Find the probability that between 500 and 600 eggs would be released. You know, the typical probability problems. Here in this video, we're going to turn it around. I'm going to ask you to find the 90th percentile of the egg spawning distribution. What's that mean, the 90th percentile? Find the point in the distribution where 90% of the eggs released fall below and only 10% fall above. I could also simply refer to that as the top 10%. So how do we do that? To solve this type of problem, we use the same two pieces we use to solve the probability problems. We use normal curves and z-scores. To begin, let's think of a normal distribution that's centered at the value 400. Why 400? Because that's the value for the mean that I gave you in this problem. The next step is to try to locate the 90th percentile. Now that means when you look from left to right in the distribution, you want to find the point in the distribution where 90% of the observations fall below and 10% fall above. The entire curve is made up of 100%, so to find the top 10%, we're going to end up way over on the right side of the distribution. I'm going to label a point in the distribution as the value of x that we're interested in, and you can see that the probabilities surrounding it are 90% below and 10% above. Typically, we label this value as x and subscript it with a 0 and call that x0, or more commonly, I'll refer to that as x0. How do we find the value of x0? Well, this is where the normal tables come in. While we don't have a normal table for this specific distribution, we do have the standard normal table. Looking up a probability of 0.9000 if I'm using a cumulative table, or the probability of 0.4000 if I'm using the inside table, will lead me to the z-value of 1.282. Alternatively, you could use some software and get to exactly the same place. What that 1.282 value will tell me is that the egg released number that I'm looking for falls 1.282 standard deviations above the mean. Why above? Because the z-score we found was a positive number. The last step is to use our z-score to determine what the value of x is. Rewriting the z-score formula so that we solve for the specific value of x leads us to the formula that's x0 is equal to mu plus z0 times sigma. Plugging in the values of the mean and the standard deviation that I gave you earlier, and the value of 1.282 for the 90th percentile that we're looking for, gives us the answer that we want. In this case, we find that the 90th percentile is 528.2 eggs. We would interpret that as 90% of the egg spawns release less than 528.2 eggs, and only 10% release more than 528.2 eggs. What if I asked you to find the bottom 10%, or what we'd call the 10th percentile? Can you see the curve flipping around, where we have a curve that has 10% in the left-hand tail and 90% above it? The z-value of 1.282 for the 90th percentile would become the z-value of negative 1.282 for the 10th percentile, and we'd solve for x and find that the eggs released at the 10th percentile would be the value 271.8. Let's do one more. How about if I was looking for the 40th percentile? Can you locate that in the curve starting at the left? Where would you get to 40%? We know that the mean would be the 50th percentile, so we're going to have to stop short. So the 40th percentile is still going to be on the left, but it's a little bit closer to the mean than the 10th percentile was. We use one of our tables to find the z-score for the 40th percentile and then plug it into the equation just like we did before. We find that the number of eggs released at the 40th percentile is the value 375 eggs. Simple, right? Every problem like this is going to be solved in a similar way. The only thing that changes from one problem to the next are the values of the mean and the standard deviation that are appropriate, and also the percentile that you're trying to find. Now it's your turn. Try some problems like this until solving them becomes second nature. And when you finish, make sure you hit that like button and subscribe to my station. That way, anytime I release new information, you'll be notified. After that, I guess it's just time for you to get to work. Good luck.